include this. Okay, so if we want to differentiate the following and we inspect, that's the first thing we need to do. So when I inspect, let's say the whole function, I see a quotient of functions. That's the first thing. Now in the numerator, I see we have sine squared 7x. So again, that one will involve what we call chains of functions or chain rule there. And in the denominator, we have again product of two functions. We can say it's 3x squared multiplied by the exponential function, or we can say it's x squared and 5e to the power of x multiplied by 3. But the main key function is to utilize is the quotient rule. Therefore, we know that dy over dx is going to be equals to, if you want, you can factor out 1 over 3 and treat it as a constant, 1 over 3. Or if you want, you can deal with it as it is, but at the end, you'll have 1 over 3 if you simplify. Okay, but I'm thinking of factoring out, but let me do it the way maybe you might have done the problem of saying x squared multiplied by e to the power of 5x, then we square the denominator. The second part, we need to multiply by the derivative of the numerator in the first term. So the derivative of sine squared 7x is going to be what? 2 sine what? Sine 7x, isn't it? Because this is to the power of 2. It's inside a bracket to the power of 2. That's chain. Multiply by 2 and subtract 1 from the exponent. Number 2, we need to multiply now by the derivative of sine 7x, which was inside the bracket of 7x to the power of 2. I hope you see it is in this way. Multiply by 2, subtract 1. And you need to multiply by the derivative of sine 7x. So derivative of sine 7x we know is going to be 7 what? Cos 7x. That is the derivative of sine squared 7x. So we're not done. We need to multiply now by the denominator. So multiplying by the denominator is going to be 3 x squared e to the power of 5x. I hope it's still clear. Now, because it's a quotient rule, we are not done. We squared the denominator and multiply by the derivative and the second function. Now we must say minus. In the second term, now we multiply by sine squared 7x. But we need to multiply by the derivative of the denominator. The derivative of the denominator. When we look into the denominator, it's a quotient, it's a product of two functions. So we need to apply product rule. So we know according to product rule, when we derivate this, the first thing we're going to derivate, let's say the first, let me do this now. So we're focusing on this now. So according to product rule, we derivate this multiplied by this plus derivative of this multiplied by this. So let's derivate x squared is going to be, let's just say 6x. Now we need to multiply by the second function, which is e to the power of 5x. In the second term, we're going to say plus, and you can say we multiply by, let me say 3x squared. So let's multiply now by the derivative of e to the power of 5x, which is going to be 5 e to the power of 5x. So we don't have ln e, it's 1. We're going to say ln of the base. So, but when you're there, at least I can assure you might have the full mark, or maybe final step as 1 mark of simplification. But sometimes the instruction will tell you simplification is not required. We squared the denominator, then we multiply by the derivative of sine squared. Then multiply by the denominator minus the first function in the numerator, then multiply by the derivative of the denominator, which was product rule. That's all. So what I'm going to do is just to simplify. That's all. So it's 2 times, let me see, I'm having 21 times 2. It's 40, 42. Sine 7x. Um, in fact, okay, because it's me, I'm just thinking of simplifying it in this way because I see it's 2 sine 7x cos 7x. This give me the compound, what is it, double angle identity. Let me just close the 7 there because it's like 2 sine x cos x. So it must go to sine 2 times 7, which is going to be 14x. I hope you see that. Do you remember that identity? You forgot. And I said you must write it that day. Sine 2 theta is equals to 2 sine theta cos theta. So I see the theta here is 7x. It's 7x. It's 2 there. So I'm going to take it to sine 2 theta. Theta is 7x. Therefore, it's going to be 14x. So sine 2 theta is equals to 2 sine theta cos theta. So I've applied that formula. So because I saw theta there was 7x, so we take it back. So 2 times the theta there, 7x, which is 14. Okay, so we're even recalling identities in the meantime. So because I saw this, not to waste time, I have that. So, but I just closed this so that you can see cos and sine 7x. So therefore, we still have our 7 times 3, which is 21, times 21. X squared times e to the power of 5x. So here we're just playing with simplification. It's not necessary. It's not necessary. Okay, 6x to the power of 5x sine squared 7x. Let's multiply here. We have minus 3 times 5 is 15. X squared e to the power of 5x sine squared 7x. All divided by. So we're just simplifying it. So 3 squared is 3 squared is 9, right? It's 9. X squared to the power of 2 is going to be 4. And then e to the power of that, 2 times that is 10, 10x. The only thing you can do, I see there's 3 here. You can take out the common factor of 3. Oh, even x, no? Even x to the power of 2. X to the power of 2. So, but not to complicate it further, let me just leave it there. But I wanted to show you can simplify further. So that's why maybe if you're solving a problem, in your textbook, you might find that the answer here it's over 3. Then here it's x squared. Here it's e to the power of, let me see, 5, 5, 5. Then take out 1 e to the power of 5 in your textbook. You can find it in that way. Maybe 3 x squared and